In this video, we're going to talk about how to solve exponential equations. So remember, we talked about this a little bit in the last lesson. So we talked about the property of equality for exponential equations. So remember, it can be used to solve exponential equations because it tells us that if a to the x equals a to the y, that means that x equals y. So when we solve exponential equations, remember, we're going to rewrite the problem so that the bases are the same. You can use the squares and powers charts to help you with this. Then you're going to simplify the power of a power by multiplying the exponents. Once the bases are the same, you're going to set the exponents equal to each other and solve for the variable. So remember the power of a power property. If a term with an exponent is raised to another exponent, you're going to multiply the two exponents together. So if we have a to the m raised to the n power, that is the same as a to the m times n. Remember, we also have rational exponents. And remember that these may be rewritten as radicals. So if we have x to the m over n, that is the same thing as taking the nth root of x to the m. The numerator m becomes the power, the denominator n becomes the index. So let's solve 2 to the x times 1 over 32 equals 32. So remember, we always want to write these in terms of a common power. So if we look at our powers chart, notice that 2 and 32 appear in the powers of 2. So we're going to rewrite this. So I'm going to leave that as 2 to the x, and then I'm going to write it times 1 over, and then that 32 I'm going to rewrite as 2 to the 5th. And that equals 32, which is 2 to the 5th. And so now I'm going to work with simplifying this equation. Well, I have a 1 over 2 to the 5th. So remember, if we have 1 over a to the n, that is a reciprocal. So we can say that is the same thing as a to the negative n. So I'm going to rewrite this as 2 to the x times 2 to the negative 5. And that equals 2 to the 5th. Well, now we're multiplying two things with the same base but different exponents. So I'm going to use another exponent property. So if I have a to the m times a to the n, remember that tells me that I can add the exponents together. So when I add the exponents together, I get 2 to the x minus 5 equals 2 to the 5th. So when I simplify this now, it tells me that I have the same base, right, which is what I was looking for. So I can set the exponents equal to each other. So I can say x minus 5 equals 5. And now I can solve this equation. When I do that, I'm going to add 5 to both sides. So when I do that, I get x equals 10. If I plug this back into my problem, I get 2 to the 10th times 1 over 32 equals 32. And if you do this on your calculator, you can go ahead and enter 2 to the 10th. Remember, you do 2 caret 10, and then that gives you 1024. And then if you multiply that 1 over 32, that does in fact equal 32. So you can use your calculator to verify that this answer is correct. So we know we don't have any extraneous solutions. X equals 10 is the correct answer. So now let's try solving this problem. We have 125 to the 3 minus 2x power equals the cubed root of 25 to the 3x minus 9 power. So there's a lot going on in this problem, so I'm going to start off by taking care of that radical. So that cubed root of 25, I'm going to rewrite that as an exponent since we're working with exponential equations. So remember, this is like a 25 to the first. So I can rewrite this as 25 to the 1/3 power. So if I rewrite that, I have 125 to the 3 minus 2x equals, and then this I'm going to rewrite as a 25 to the 1/3 to the 3x minus 9 power. So now I have a power raised to another power, right? So I have like an a to the m to the n situation. So I'm going to multiply those two exponents together. Okay, so if I do 1/3 times 3x minus 9, remember that means that 1/3 will distribute to both terms. So 1/3 times 3x is just x, and then I have minus 1/3 times 9, which is 3. So this is the same thing as 125 to the 3 minus 2x equals 25 to the x minus 3. Well, now I need both of these to have the same base. Okay, so if I look at my powers chart, notice that 125 and 25 are both powers of 5. So I can rewrite these both as powers of 5. So the 125 is going to be 5 cubed, and then that's going to be raised to the 3 minus 2x power. And the 25 is going to be 5 squared, and that's going to be raised to the x minus 3. So now I'm going to multiply these exponents together. Okay, so on the left side I have 3 times 3 minus 2x. So if I distribute that 3, that's going to give me 9 minus 6x. So I have 5 to the 9 minus 6x equals, and then on the right side I have 2 times x minus 3. So I'm going to distribute that 2, so that gives me 2x minus 6. So we have 5 to the 2x minus 6. Now finally I have the same base, so I can go ahead and set those exponents equal to each other. So I have 9 minus 6x equals 2x minus 6. So now I just need to solve this equation. Since this is a positive 2x, I'm going to do the opposite and I'm going to subtract 2x from both sides. When I do that, I get 9 minus 8x equals negative 6. So now I need to solve that 9 minus 8x equals negative 6. And I'm going to do that by subtracting 9 from both sides. So when I do that, I get negative 8x equals negative 15. Now I need to divide both sides by negative 8, and that gives me x equals 15 over 8. So remember, you always want to go back and make sure that your answer does make sense in the original problem. So that tells me that 125 to the 3 minus 2 times 15 over 8 equals the cubed root of 25 raised to the 3 times 15 over 8 minus 9 power. So when you simplify this, and like I said, you can use your calculator, you're going to get 125 to the negative 0.75 power equals 25 to the negative 1.125 power. And when you do that on both sides, so on the left side, you'll get 125 to the negative 0.75, and that gives you 0.0267496, and then if you do 25 to the negative 1.125 power, it gives you the same value. Okay, so this answer does check out so that we know it is not an extraneous solution. Okay, so x equals 15 over 8 is the solution to this problem. So now let's try solving this equation. We have 1/4 to the negative 4 minus 3x power equals the cubed root of 2 to the negative 3x squared power. So once again, we want to think about rewriting these so that we have the bases the same. But first, I'm going to take care of that radical that I have. So the cubed root of 2, I'm going to rewrite that as 2 to the 1/3. So I have 1/4 to the negative 4 minus 3x equals 2 to the 1/3 to the negative 3x squared. So once again, on the right side, I have two powers that are being multiplied together. And so when I do that, that is going to give me negative x squared. So I have 1/4 to the negative 4 minus 3x equals 2 to the negative x squared. So now I'm going to work on rewriting these. Notice that 4 and 2 are both powers of 2. So this is the same thing as 1/2 squared, and that's being raised to the negative 4 minus 3x. And that equals 2 to the negative x squared. So that 1/2 squared, I can write that as 2 to the negative 2, and that's raised to the negative 4 minus 3x, and equals 2 to the negative x squared. So I'm going to multiply that negative 2 times negative 4 minus 3x. So when I distribute that negative 2, that gives me negative 2 times negative 4, which is 8, and then plus, okay, I have negative 2 times negative 3, so that's going to be 6x. So I have 2 to the 8 plus 6x equals 2 to the negative x squared. So now I have the same base, so I can set those exponents equal to each other. So I have 8 plus 6x equals negative x squared. Since this is a quadratic, I need to now set it equal to 0 to solve for x. So I'm going to add x squared to both sides. And when I do that, I get x squared plus 6x plus 8 equals 0. So now I need to solve this quadratic. I'm going to solve it by factoring. So when I factor, I need two factors of 8 that are going to add up to 6. Since 8 and 6 are both positive, I need two positive factors. So the factors of 8 are 1 and 8, and 2 and 4. And 2 and 4 are the correct combination that add up to 6. So this is going to factor into x plus 2 times x plus 4 equals 0. And that means that I can set each factor equal to 0 and solve for the value of x. So when I do that, I'm going to subtract 2 from both sides. That gives me x equals negative 2. And then here I subtract 4 from both sides, which gives me x equals negative 4. So now I need to make sure that none of these solutions are extraneous. So I'm going to plug them back into the original problem. So when I plug in negative 4, I get 1/4 negative 4 minus 3 times negative 4 equals the cubed root of 2 times negative 3 times 4 squared. And so that gives me 1/4 to the 8th power equals the cubed root of 2 to the negative 48 power. So when you do this on your calculator, it's going to tell you that 1.526 times 10 to the negative 5th does equal 1.526 times 10 to the negative 5th. So this answer does work. So x equals negative 4 is a solution. Let's now try x equals negative 2. So we have 1/4 to the negative 4 minus 3 times negative 2 equals the cubed root of 2 raised to the negative 3 times negative 2 squared. And we do this on both sides. You get 1/4. Negative 4 minus 3 times negative 2 is going to give you 2. And that equals the cubed root of 2 raised to the 2 squared is 4. 4 times negative 3 is going to be negative 12. And this is going to tell you that 0.0625 equals 0.0625. So this answer also does work. Okay, so x equals negative 2 and x equals negative 4. Both of these values are solutions to our equation. So now let's try solving this problem. We have 8 to the x plus 2 over 16 to the 2x equals 4 to the x minus 6. So once again, we're looking to make this so that everything has the same base. Well, if we look at our powers chart, notice that 8, 16, and 4 are all powers of 2. Okay, so let's rewrite all of these using powers of 2. So when we do that, we get 2 cubed to the x plus 2 over 2 to the 4th to the 2x equals 2 squared to the x minus 6. Okay, so on the left side, we need to multiply that 3 times x plus 2. And so that distributes, which gives us 3x plus 6. Okay, so in the numerator, we have 2 to the 3x plus 6 over, and then we have 4 times 2x, so that's 2 to the 8x. And that equals 2, and then we have 2 times x minus 6. So we're going to distribute that 2, so that's 2x minus 12. So now we need to kind of simplify this problem, right? So notice that we have a place where we can use that quotient property, right? We have an a to the m over a to the n, same base but different exponent, and when we're dividing, we're going to subtract those exponents. So what I can do here is I can say this is 2 to the 3x plus 6 minus 8x equals 2 to the 2x minus 12, okay? And when I subtract those exponents, I combine that 3x and minus 8x, so that gives me 2 to the negative 5x plus 6 equals 2 to the 2x minus 12, okay? So now I have the same base but different exponents, so I can set those exponents equal to each other. So I have negative 5x plus 6 equals 2x minus 12. Okay, so now to solve this equation, I'm going to do the opposite of 2x, and I'm going to subtract 2x from both sides. So when I do that, I get negative 7x plus 6 equals negative 12. And now I'm going to subtract 6 from both sides, and when I do that, I get negative 7x equals negative 12 minus 6, which is negative 18. Then I divide both sides by negative 7. And when I do that, I end up with x equals 18 over 7. Okay, so x equals 18 over 7 is the solution to our equation. So now you can go ahead and pause the video and try this example on your own. So in this problem, everything can be rewritten as a power of 3. So I rewrote it as 3 to the x times 3 squared to the x plus 1 equals 3 cubed. Since we're multiplying two terms with the same base, we can go ahead and add those exponents. So we get x plus 2x plus 2, and then when we combine those, we get 3 to the 3x plus 2 equals 3 cubed. Now we have the same base, so we just set the exponents equal to each other. So we have 3x plus 2 equals 3, and then we subtract 2 from both sides and divide by 3 to give us x equals 1/3. So remember, you can solve exponential equations using the property of equality that tells us that a to the x equals a to the y if and only if x equals y. To use this property, the bases must be the same. Use the powers chart to change the values in the equation so that the bases can become the same.